Thank you all for joining us for today's mobility webcast, iPhone and iPad Security, presented by Simon Guest. My name is Meredith Mead. I'm the marketing coordinator for Nudesic and the moderator for today's webcast. This webcast is presented by Simon Guest, Nudesic's Director of Mobility Solutions. If you're all logged on, you should be able to see the title site that states Mobility Webcast, iPhone, iPad Security. There's a brief intro earlier regarding features within Live Meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using the scene chart feature within Live Meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded. We'll be sending out a link to view this recording once it becomes available. If everyone is ready, please make sure your seat color is green. And at this time, I'd like to turn our presentation over to Simon.
Excellent. Thank you, Meredith. And thanks, everyone, for joining for today's webcast. As Meredith mentioned, the title of this one, or the theme of this one, is iPhone and iPad security. And really, the premise of delivering this one today has really been due to a number of customer engagements that we've been working with. And often when we speak to customers, many organizations, they have a lot of questions about just security of devices in general, but in specifically kind of iPhone and iPad devices. And a lot of questions can fall into different categories. So for example, a lot of organizations don't want their employees doing certain things on the devices. So maybe it's going to YouTube or downloading stuff from the App Store. Is it possible to configure a policy on the device? A lot of organizations are worried, well, what happens if the employees leave devices in public places and they get picked up? What happens if I leave my device on a bus or the train or the plane? Another common question is, well, how do I make sure that the communication from the device is secure? How can I make sure that the Wi-Fi communication or certain web communications don't get intercepted? A fourth one is for developers that are writing an application. So how do developers make applications secure? And then finally, just kind of wrapping this up, well, what's the other bad stuff? What other bad stuff should organizations be thinking about? So what's out there? What are people doing in say the hacker community? And what's important to know with these devices? So in terms of the agenda for the webcast over the next 45 minutes, I really wanted to take each of these sections in turn. So looking at policy, looking at data on the device, looking at the network, the application side, and then ending on some of the bad stuff. And I walk you through some of the scenarios here and hopefully give you kind of an overview of different facets of security for both iPhones and iPads. So let's start with number one. So let's imagine that you're an organization. You don't want your employees doing certain things on the device. What can be locked down and how do we configure policy? So the first element in policy that you've probably seen today is called the passcode policy. If you own a device today, maybe an iPhone or an iPad, you may have implemented this. And really this is the so-called first line of defense for device security. So the way this works is the user gets prompted for some kind of PIN code or passcode that's typically entered when the device is started or when the device wakes up from being locked. And without the PIN code, certainly for the iPhone, the device is going to let you do emergency calls, but nothing else. So setting this up on the device is fairly simple. You can turn it on, off. You can switch between a simple, which is a 4-digit PIN, or a more complex passcode. You can tell the device to actually do a remote wipe if a certain number of incorrect attempts have been tried. And this can also be used in combination with the auto lock. So if my device is left unused for, let's say, 10 minutes, then it can go into a sleep mode, and then when it comes back, it can automatically prompt me again for this passcode. So this is all fairly simple and all stuff that's probably you've already seen on the device today. Now, one of the interesting elements of this is, of course, in an enterprise environment, making sure that devices can be locked automatically. So obviously, you may or may not trust your employees to set this up. And one of the things that can help here is actually deploying this policy through Microsoft Exchange. So if you're an organization that runs Microsoft Exchange, you can actually configure a policy to be distributed to the device upon the user configuring ActiveSync. So when the user sets up their email, if there's a policy attached to their account on the server, then the user will be prompted to install it, and this can actually configure quite a few things on the device, such as the password or the passcode locking. So if you're using Exchange Server 2003 today, the elements in yellow are supported, so you can force users to require a passcode, allow a simple or a 4-digit PIN, or an alphanumeric. You can set the passcode length, you can set auto lock, and you can set the maximum number of failed attempts before the device actually undergoes a remote wipe. If you've upgraded to Exchange Server 2007 or 2010, then the profile actually allows you to do slightly more. So there's a minimum number of complex characters, a minimum password age, and you can also enforce a passcode history as well. So certainly with those later products, you can get fairly granular about what type of policy that the user should be enforcing. Now, of course, you need to be nice to the new user as well. You can set up a really nasty, long password, very complex length that expires every week, and that's probably not going to win you any friends as an IT administrator, but certainly gives you an idea of some of the combinations that you can use. So another way, or as we kind of explore policy in more detail, obviously sending policy through Microsoft Exchange is one way, but also you can actually configure quite a lot on the device if it actually has a physical connection. So if I'm able to access the device, let's say I'm provisioning them for users prior to sending the devices out in my organization, I can actually connect the device via a USB cable. I can set all of the possible configuration options for the passcode, but also through a tool that ships in the SDK, I can configure a lot more on the device as well. So this is a tool called the iPhone Configuration Utility. It ships with the SDK and effectively gives you a lot of categories that you can configure on the device. One of those is certainly passcode. And effectively, you build up a series or one or more profiles. A profile is an XML document that you can choose to sign, and then you can either deploy this to the device or you can share it or export it. So I could export it as an XML configuration file and do some stuff with it. Equally, if I had the device locally here, I can just literally tell the tool to deploy a particular profile to my device at that particular time. So what does the configuration tool and policy allow you to do? Well, there's certain restrictions on device features that can be done fairly easily. So I can restrict the user from installing applications at all from the App Store. Let's say that I have a policy that says I don't want any additional applications to be launched or to be downloaded. That can be done. I can restrict use of camera and FaceTime. So if I want to prohibit use of the camera for any reason, that can be done. I can prohibit screen capture. Screen capture on the iPhone or iPod devices are done when you hold down the top button and then click the home. And certainly if I want to prevent users capturing the screen that way, that can be done as well. And then various other restrictions, such as the ability to sync while roaming, the ability to actually make calls on the device. Maybe that's something that you want to lock down. Things like in-app purchases, and then certain gaming restrictions. So in addition to the device feature restrictions, the policy can also be used to restrict certain applications as well. So if we want to lock down the device so it can't access things like YouTube or iTunes, that can be done as well. Equally, if we didn't want the user surfing the web, or there's actually several settings under Safari, but we can restrict use of things like cookies or certain elements of JavaScript to create a more locked down kind of web experience. And then finally, there are quite a few restrictions on content ratings as well. So this is a regional setting, and the way this works, you can actually restrict the maximum content rating level across numerous kind of media on the device. So let's, for example, say that I have a device for, I don't know, my younger son. I could actually limit the content rating to something like PG-13 across movies, TV shows, and apps. And then anything that he tried to download would actually not work if it fell above that particular rating. Now, policy, as you can probably imagine, is actually just more than restrictions. You can add additional settings for configuration as well. So this is really useful in an organization if you want to pre-configure things like Wi-Fi access points or email or maybe some directory services. What's important to notice here, however, is these are not really restrictions. This is more about configuration in terms of imaging the device and then sending it out to users. So I could set up my email server to be a certain value, but really there's nothing to stop the user from overriding that or deleting or creating a new account. There is one exception here, and this is to do with things called web clips. Web clips are icons on the kind of home screen, the springboard screen, where we can actually fix those so that they can't be removed. So if you wanted, let's say you had a corporate homepage, and you wanted an icon on the home screen, and you didn't want users to ever remove that, then that's certainly one icon you can add, but also a restriction that you could make to prevent users actually taking that icon off. Additional settings for policy include a lot of security settings. The iPhone and iPad devices support something called SEEP, or Simple Certificate Enrollment Protocol. This was a protocol actually originated and defined by Cisco, and enables certificates to be auto-enrolled on devices. So you may have done this in the past where you've tried to get a certificate down to a device. It can be pretty complex. You've got to bind it, or you've got to connect it to the USB cable and then run the configuration utility and send it. This protocol that's supported actually allows you to kind of do over-the-air certificate enrollment. And equally, it's also implemented in Windows Server 2008 R2 under a service called the Network Device Enrollment Service. And then finally, on the policy side, there is a few advanced settings, certainly for GPRS access points. This is kind of where you're overriding the data points that are given to you by the provider, such as AT&T. One of the interesting points in here is the ability to set a proxy server. And this can be done for GPRS access points, but actually doesn't work on Wi-Fi and 3G networks. So we've actually had a lot of customers come to us and say, well, can you configure the device so that it automatically goes through the proxy server? And the answer actually is no. And the reason for that is that there's a potential compromise with a kind of evil profile. So if I was an evil person, a hacker, I could potentially create a profile that had my proxy server as part of that profile. And if the user were to download that, they may not necessarily notice that everything's going through my proxy server, yet I could actually look at that proxy server and see what they're doing, what sites they're visiting, anything being sent in clean text. And that used to be possible to configure in the policy. However, that was actually removed, I think, several versions ago by Apple, and it's no longer, you don't have that ability to configure that anymore. So certainly something to bear in mind. Getting this policy to users' devices can be done in a number of ways. So the easiest way is through the USB cable directly to the device. This is, as you saw, through the iPhone configuration utility. However, as I mentioned, these policies are just XML files. So what you end up with is what's called a .mobile config file, and you can specify a level of security on that as well. You can sign it, and then you can also encrypt it on or for a particular device. And really, you can do anything with this config file that you could with any other XML file. So I could email it to users. I could put it on a web download link that says configure this iPhone now. I could SMS it to users. It's fairly easy to get to users. Of course, it does require the user to actually accept the policy, and the users do have the ability to say this policy is going to adjust these particular settings. But all in all, it's fairly easy to distribute and get around. Now, the whole concept of policy leads us into a fairly hot topic today called MDM, or mobile device management. And when we look at many organizations and they look at MDM today, it really falls into three different categories. Number one is remote configuration. So the ability to take these profiles that you define and push them to devices. And number two is the ability to query devices remotely, often to build up things like an asset database. So what devices are on my network, what are they doing, what OS level are they on, what security settings they have, that kind of thing. And then also often there's kind of the need for remote management as well. So I want to remote wipe a device or remote lock it. Maybe I want to help the user with clearing out a passcode that they may have forgotten. Implementing MDM today, however, is really down to the number of products and vendors that are supported. So as of iOS 4.2, Apple did release an API for MDM. However, it has very little public information there today. So if you're really looking to build your own MDM server, that's going to be fairly tricky. And it looks like Apple have a separate agreement with MDM providers to actually kind of keep this within the kind of product or vendor space. If you look at those providers today, there's kind of three popular ones: AirWatch, Sybase, Afaria, and Mobile Iron. And of course, if you're interested in the space, you can look at each of those vendors and get an idea of the types of things that they support. And what was interesting, I think, just a couple of weeks ago, is that Microsoft announced MDM support in an upcoming version of System Center Configuration Manager. So that's currently in beta, but certainly I think this will be the first example of a kind of true MDM support coming to a fairly large and widely adopted products like SCCM. Hopefully this has given you some kind of overview of what can be done on the policy of the device, which is certainly useful when you're kind of restricting what employees or users can do on the device. But I wanted to move on and say, well, what does the data security look like on devices today? So what would happen if I left my device on the bus or train or plane or in a taxi, and someone got hold of that? What could they do? What could they find out? Well, if you read Apple's blurb, they'll tell you that all devices support hardware-based encryption. And this ultimately is true, and anything that's written to the flash storage on the device is actually encrypted with a 256-bit AES key. So very secure in terms of the key that it's using, and this is all hardware-based, so this is something that you can't turn off as a user. However, it was primarily designed for remote wipe as opposed to security. So in the way that remote wipe works, if you choose to wipe a device, it doesn't actually overwrite the data with zeros or ones, that would take certainly a long time, certainly for like a 32 gig device. What Remote Wipe actually does is just delete this key. And as a result, that data is virtually inaccessible. I mean, 256-bit AES key is very secure. You're going to have a number of lifetimes to do a brute force on that thing. However, given that it was designed for Remote Wipe, there's actually quite a lot open in terms of what can be done to bypass this key. So there's several tools available, and a savvy hacker, as I call them, if they had easy access to the device, even if it's PIN code protected, can boot the device in what's called a recovery mode. And then a number of tools can be run on that via that kind of recovery connection. And basically, you end up not getting hold of the key, but accessing the device such that it gives you the data bypassing that encryption mode. So it's actually fairly simple. Even though the actual bits are encrypted on the device, it's fairly simple to circumvent that by kind of going underneath the covers into a recovery mode and then extracting the data through that way. Now, Apple have responded to this. They, as of releases of iOS after 4.2, they included a new set of APIs called the Data Protection API. And how this works is anything that's written to storage on the device is still encrypted with a 256-bit AES key. However, that key itself is derived from the user's passcode. So what the way this works is you've still got an encryption key, but the derivation for that key is actually done based on the passcode that you enter. And of course, as you can imagine, the strength of that data protection is going to be dependent on what type of passcode that you pick. So if you pick a simple 4-digit PIN, 1, 2, 3, 4, it's still more secure than it was, but it's not going to actually take much to actually break that. The way typically this works is there's a standard called PPK-DF, which is a password-based key derivation function, and even with the number of iterations that they have within the system today, it still means that a brute force attack could probably crack around 20 passwords per second. So even with a 4-digit simple PIN, then you're talking maybe 8 minutes, assuming there's no lag in between them. So it offers a little protection, but not much. However, if you choose to do a more complex passcode, something with kind of alphanumeric characters, then certainly this becomes quite compelling. However, there is a caveat with all of this, and that caveat is that it only applies to applications that actually use the data protection API. So this is not in any way default. This has actually got to be enabled by developers of applications today. One of the applications out of the gate that supports this as of 4.2 is Mail. So by default, your email storage is encrypted, which is useful. But if you've loaded in any third-party apps, they may or may not be using these APIs depending on whether the developers followed this scheme. One of the interesting things from a developer perspective is if you do end up using this API, you actually have to now handle failure. So because the key is derived from the passcode, and that key is actually forgotten when the device is locked, if you have an application that uses this API but runs in the background, it won't actually have access to the file. The reason is that the actual passcode isn't available if the device is locked, obviously. So therefore, there's no way of getting the decryption key just because that passcode is not available. So from a developer standpoint, if you are implementing this API, it's kind of important to know that it really only works for these kind of active foreground applications, or certainly the functions within there, and you would really not want to use this if you're writing any background processing, because you're not going to get access to those files as a result. Now, another element of data security on the device is something called the keychain. So on iOS devices, the keychain is an encrypted container that typically holds passwords for your applications and services. So you enter a password when you fire up an app for the first time, or your email password. Typically that is stored in the keychain, so that when you further fire up that app in the future, it's not actually required. And the keychain was kind of brought to light a few months ago via a video and a paper that was created by the Fraunhofer Institute called Lost Phone, Lost Passwords. And I've included the link to the paper in the video on YouTube. And what they were able to do is access the keychain using the techniques described in the last section. So they actually jailbroke the device, or put the device in some kind of recovery mode. They booted it, they copied a script to dump the contents of the keychain, which in itself wasn't that important. What was important, however, was when they looked through the keychain, they found that some passwords, but not all of the passwords, were revealed. And what this kind of comes down to is the level of encryption that's supported within the keychain today. So as a developer, when you write a password to the keychain, you kind of have three primary attributes or methods that you can select. You can say that this password is always accessible. You can say that this password is accessible when the device is unlocked. And you can say that this password is accessible after the first unlock of the device. And what the Fraunhofer kind of Institute and this research really found is that a lot of developers were just using the first option, which was just, I'm going to set this password to be accessible always. And while this is really convenient from a developer point of view, if you kind of take the device through a lot of these unlocking steps, you find that this actually gets stored in plain text. And as a result, there's this kind of a pretty major compromise there. So when looking at these kind of three attributes here, there's kind of ways to go and ways to avoid. So certainly I think the recommendation here is to try and avoid this API that states that everything in the keychain is always accessible. It's going to give you no protection, and of course, you have to understand what it takes to break one of these devices. But if that is ever done, then ultimately your passwords are at risk. The next two are kind of the two recommended methods. So if you have an application that's just running in the foreground, then the API that says it's accessible when unlocked is certainly the way to go. And then if you have applications that need your password in the background mode, maybe it's an email application or some service that's running in the background that needs authentication to a backend service, then this really is the third option here, which says that it's accessible after the first unlock. So the device is unlocked, and then for the duration of that the device is on, then that password is accessible. But I think this is okay, because if you look at a lot of the jailbreaking or the kind of recovery modes, you do actually need to reboot the device, after which that's going to be lost. Now that we've covered some of the data kind of elements of the phone, obviously one of the concerns for many organizations is kind of network security. So if we can ensure that the data on the phone is secure, but how do we make the same kind of assurances for things going across the network? And obviously the kind of standard security measures you would expect are kind of supported by the devices. So SSL and TLS for HTTPS-based web applications. You've probably seen this already today. From the wireless security, iOS devices support multiple schemes. So it goes from WEP all the way up to WPA2 Enterprise, which is again very similar to a lot of the other wireless devices that you're going to find today. Obviously, the same as you would find on these devices, you certainly want to avoid WEP, and you want to stick with either WPA or WPA2, just because of the key security there. And also the wireless supports a lot of authentication protocols. So you have various routers or various authentication devices, you're going to find some pretty good support here. One of the features that was introduced in 4.2 was the concept of a VPN support. So on either the iPhone or the iPad today, it's possible to do one of many supported VPN schemes. These range from Cisco's IPsec. You can do an L2TP VPN. PPTP is a very popular point-to-point tunneling protocol VPN. And you can also do VPN over an SSL connection as well. And then in addition to the ones that are supported by default on the device, there's many more App Store clients from things like, from organizations like Juniper, Cisco, and F5 that you can download and configure if you're using one of these. In addition, many, if not all of these settings are actually deployable via the configuration protocol, the configuration profile. So if you are deploying devices into your enterprise and you have a VPN already set up today, it's probably going to be a good idea to think about creating a profile that contains all of that VPN information so that users don't have to go through the rigmarole of setting them up themselves. Authentication today is primarily based on two factors. They support, or the device supports a username and password for many of the schemes. It supports X509 certificate if you are using the Cisco IPsec solution. And then out of the box, the device will also support a couple of two-factor authentication schemes as well. These are, you've probably seen these through other devices. They are effectively one-time passwords. You typically find them on a keychain, an LCD-based keychain, and it keeps updating the password, say, every 30 seconds. So two popular schemes are supported today: RSA Secure ID and then CryptoCard. And both will work with the VPN connection on the device to provide an additional layer of security through these connections. Now that we've covered kind of policy, data, and network, what are the things that are important if you're writing an application? So if you are developing your own application and you do want to make that secure, what are the other factors that really you need to be thinking about? Well, this is kind of really interesting, I think, for developers. Certainly developers that have written other services, maybe a website before or some other application before, because the concept of authentication and authorization doesn't really exist on these devices. So for authentication, there's no concept of different users, different accounts or passwords, and really the device believes you're authenticated if you've entered the PIN code. I mean, there's really not much more that the device can do in terms of figuring out who you are as a user. And likewise, as a developer, there's no way of reprompting the user for the PIN code or different PIN codes or locking the device in a certain way. So really there is quite a restriction on the actual device in terms of what authentication and equally authorization looks like as well. I mean, there really are no concept of roles or permissions on the device. It really is this one-time kind of access through the PIN code. So as a developer, if you do want to implement some kind of authentication and authorization, what you're typically going to have to do is set up a set of services within the organization that's going to support that for you. So you can imagine setting a set of server-side resources, like an authentication service, and then having your application call that directly, and in turn prompt the user for, let's say, a username and password, which is going to connect to a back-end LDAP store or Active Directory store in order to actually authenticate you correctly. And there's a few kind of gotchas or a few caveats here. From the authentication side, the default connection mode in iOS is called NSURL connection. This out of the box does not support NTLM. So certainly that's one factor if you have maybe things like SharePoint that you're trying to authenticate against, or your own service that you want to do NTLM against. And as a result, you kind of have to either do everything over a basic auth over SSL, or possibly use one of the third-party libraries such as ASI HTTP requests to get this done. With that said, however, the SSL support out of the box is actually pretty good from a developer point of view. So many connections that you make programmatically are going to support SSL with no additional kind of logic. And then there's also delegate support for kind of intercepting the SSL request as well. So things like dealing with invalid certificates, useful in a test environment, or support for client-side certificate requests if you've got a certificate on the actual device that you're trying to sign the SSL request with can also be done fairly easily as well. One other factor that's also interesting for developers is, of course, password storage. And we talked a little about this earlier, but certainly in many applications today, certainly the earlier applications, a lot of developers chose to store the passwords in NS user defaults, which is the same container or the same kind of store that you would use for other application or other defaults for the application. And from a UI perspective, this looks logical. When you go into settings, you see that the username and password is actually, or the password itself appears to be secure because it's kind of obfuscated from a UI point of view. But it's really very, very easy to access this. I can hook the device up to the file system or do a simple backup or use tools like iPhone Explorer. And I find that once I can get the user defaults for that particular application, which is just effectively a text file, I can actually then look at the password very easily. So really, from a developer recommendation, certainly the keychain is the way to go for your application passwords. And then, of course, thinking about the types of things that we spoke about, or the APIs that we spoke about in the previous section on this. As a developer, you may also have a need to do cryptography or kind of a cryptographically encrypt or sign your data. And this today is done through two different sets of APIs. So iOS supports asymmetric support. This is kind of public and private key support through a service that's called Certificate Key and Trust Services. And this is fairly extensive. You can use this API to manage certificates, create certificate signing objects, certificate requests, pull in certificates and create different public and private keys. So it's a pretty rich set of APIs that will certainly do most, if not all, of the kind of functions that you're looking for. Symmetric support, so this is where you have a shared key that both parties rely on, is actually done through a library called a Common Crypto. And there's really two kind of ways or two scenarios for this today. The first is symmetric encryption. So this is where you want to do a fast symmetric encryption. You are going to import the library, and then you're going to run an API called ccrypt and give it a key, and that's going to return you some ciphertext that you'll probably store in a database somewhere. Fairly popular algorithms supported today, DES, Triple DES, and AES 128, with the recommendation being that AES 128 is going to offer you the best security. However, symmetric encryption is most likely to be used for digital signatures. So a good case is where you're accessing data in a database, and then you have a row in a database that you want to generate a hash for. You're probably going to use the library. It's called Common Digest, and then you can pick one of the digest algorithms, maybe SHA-256 or MD5, to actually sign or create a unique key based on that set of data. In addition, just finally, one of the digital or the digest algorithms supported is also HMAC, which is actually very useful for creating digital signatures, but also based on a key. And there's certainly a lot of services. So, for example, the storage service in Windows Azure uses this set of algorithms today. And then finally, on the cryptography support, one of the interesting things, just from a pure hardware perspective, obviously, when you're dealing with cryptographic data, it's really important to get as unique random number as possible. Now, this is done automatically for you in the previous APIs, but this API itself is also exposed kind of in the clear as well. So there's an API called secRandomCopyBytes, and what this will do is it will generate or create a cryptographically secure random number based on various hardware aspects of the device, so such as the accelerometer, the compass, various radio baseband kind of signals, which you probably won't use, but it's kind of interesting to know that given the proliferation of the devices, and certainly the sensors that are now shipping on these types of devices, the actual types of things that you can do in this particular area. Up until now, we've kind of now covered the four kind of main aspects of the presentation: the policy, data, network, and the application. I kind of wanted to end with a section called bad stuff, and this may be a little an interesting word to call it, but really to kind of take a look at the other side and see what bad stuff is kind of going on. And I want to start with the concept of jailbreaking. So this is a term that I've used in the webcast, and you've probably seen a lot of in the media as well. Jailbreaking is ultimately the process of unlocking a device to gain full access to that device. It's also known as rooting a device or getting root access to the device. And really the purpose is to get more control over the device and to have the device do things that couldn't be done probably due to previous restrictions. So, for example, a jailbroken phone, you can import things like custom ringtones, wallpapers. There's a whole library of applications that only run on jailbroken devices for things doing things lower at the network level, that kind of thing. And as you've probably seen in the media, there's this constant battle or leapfrog, I guess, between jailbreakers and Apple at the moment. So Apple will release an update, then a few weeks later, there's a jailbreaking team. One of the most popular teams is called the iPhone dev team, ironically, and they'll release a jailbroken update for that. And you kind of get this kind of leapfrog effect between these jailbreaking organizations and Apple trying to push out new updates to try and stop jailbreaking. The question that many people ask is, well, is it legal to jailbreak a device? And actually in the US, there is an exemption under DMCA, which is the Digital Millennium Copyright Act. That states that this actually is not an illegal practice. However, it will void your device's warranty. So if you do try and jailbreak a device, you run into trouble and the device is no longer usable, kind of good luck taking that device to an Apple store and trying to explain your way through that. Equally, jailbreaking is not the same as SIM unlocking. SIM unlocking really is about using or unlocking devices to use different SIMs from different operators. Jailbreaking is really much more at the OS level, where you're ultimately installing a new broken version of the operating system underneath. Jailbreaking in the enterprise is kind of interesting. There's kind of two factors here to understand. Number one is the difference between tethered and untethered jailbreaking. So untethered jailbreaking means that you don't require a USB cable and software to reboot the device. So if you have a tethered jailbreak, then this will work. The phone will operate as normal. But if you were to ever reboot that phone, you're going to actually have to require the USB cable and a particular piece of software to get this phone working again. And what you kind of find is that most of the jailbreaks or the jailbreak images after 4.2.1 require a tether. However, saying that and reading that on the slide, I think it was only last week that they released an untethered 4.3.1. So just goes to demonstrate some of the leapfrogging I was talking about earlier. And of course, one of the most important things in the enterprise is thinking about security risks. So if employees walk in with jailbroken devices, what does this mean? And there's probably a lot more media speculation than there are actually hard case kind of use cases of this happening. There are two that kind of stand out, and both of these actually based on the fact that when you jailbreak a device, it's possible to install an SSH server on the device. And if you don't change the default password, then ultimately you're leaving the device or the device can be compromised in that way. And there was kind of two examples of this recently. One is through a worm called iKey, and fairly benevolent. It changes the wallpaper to a Rick Astley background, which may or may not be an issue, I guess. A more malicious one was a Netherlands-based botnet-like worm, which actually kind of searched your device for the master password file and then uploaded it to one or more servers in Lithuania. So again, these are fairly rare, but certainly do highlight one of the security risks of doing this. Now that we've covered jailbreaking, I kind of wanted to end the bad stuff section, but just by taking you through three kind of top scenarios that you may or may not find, but certainly things that people have certainly attempted and things that you should watch out for. Number one, or scenario one, is having public configuration profiles. So a lot of organizations, they built up a public configuration profile and they post it to their public website, or maybe they email us or do something that's publicly visible. And it certainly is possible to, just because this is an XML file, is to grab a hold of that XML file and then scan that for plain text details. So if you have a configuration file that is configuring, say, wireless LAN settings, you will find that your SSID and your password will be in plain text for that XML file. So to mitigate this, there's really two ways of doing this today. Number one is to encrypt it, and so this has to be done at a device-specific level. Number two, which is probably more doable, is to make sure that you're placing the mobile config files behind an authenticated page somewhere. So you really want to avoid people Googling, grabbing your mobile config file, working out which organization you are, and then kind of sitting outside your building with now the wireless LAN SSID and password. Scenario number two is a kind of evil configuration profile. This is where an attacker could potentially generate an evil mobile config file. It's very easy to sign this and make it to look authentic, and then obviously SMS it to your victim or their victim, or fake them into some way of installing it. Mitigation around here is really to a couple of things. One is it's possible to create a locked default profile, so that you have a default profile that overrides anything else that gets applied. Of course, the second mitigation here is, of course, user education, making sure that people don't arbitrarily decide to install these configs. And also, when you look at config, I mean, yes, it's an annoyance. Certainly, if you have a config that locks down a lot of functions of the device, but just like we spoke about earlier with the proxy server being removed from the configuration option, there's only so much that can be done here. So yes, it's an annoyance, but in terms of extracting data from the phone, you're not going to find much of a risk there. And then the third scenario is what we've been talking about a lot in previous sections, kind of bypassing the PIN code or at least doing a forensic recovery of the disk. So the scenario is the attacker has physical access to your device gets lost or stolen, and then even though you think it's secure because you've locked this thing down with a PIN code, it can still be placed in a recovery mode to override that protection. Mitigation of this, a few things. Obviously, making sure you don't lose the device is probably number one. Number two, making sure that applications that you've loaded on there that deal with sensitive data use the data protection API by default. And then, of course, number three is correctly using those keychain algorithms to ensure any passwords stored on the device are not stored in a format that they can be extracted in clear text. Well, that kind of brings us to the end of the scenarios here, and I kind of just wanted to wrap up with a quick conclusion, a few points here. Number one, as you've probably seen, there's a lot to consider when you're thinking about security for devices in general, but specifically the iPhone and the iPad. I always recommend dividing the problem into 4 ways, thinking about how you can lock the device down, how you can secure the data, secure the network, and secure applications. But equally, I think it's important to understand what's the bad stuff as well, what's going out there and what's available. Secondly, your device is only as secure as the weakest link. So you believe that it's secure because you've put a 4-digit password on it, but if you're not thinking about the rest, then that certainly leaves you vulnerable. And thirdly, it's always important but also interesting to think like a hacker. So what tools would they have? What would they try? And ultimately, what's the worst that could happen if they got hold of your device? And it's certainly interesting to start there and then think backwards to what you actually need to do to mitigate a lot of that. Can be certainly helpful. With that, here at Neudesic, we have a very active mobility practice, and certainly, as I mentioned at the beginning, many customers, we're working with many customers on mobile projects that include a very high degree of security. As a result, we've kind of got a couple of reviews or options that certainly many customers are interested in. The first is what we call the Application or Device Security Review. This is really kind of almost like a simulation of losing one of your locked devices. So you have a device, you install it with the applications that your organization uses, you give it to us for 24 or 48 hours. We can run it through a series of tools that the hackers have, and then the output of this is a full report of, okay, this is what we found, these are the passwords we got, this is the data that we got, and then up to you to ensure that that this is something that you should or should not be concerned about. Secondly, we also do a lot of work with organizations kind of up-leveling this, so looking at security and specifically with the kind of larger picture for what an organization's mobile strategy review should look like. So many organizations are thinking about mobility, or it's kind of happening underneath them. Kind of employees are they're going to the Apple store one weekend, they're bringing in devices, and I think the experience that we have here at Neudesic, we can work with organizations to kind of say, well, look, this is how we can kind of put this in the right direction, and also use these devices to kind of get more out of the business. So with that, I would like to thank you for your participation today. It's been a pleasure. I've left my contact details up on the screen there, and now I'm going to hand it back to Meredith, who's going to take us through some questions.
Thank you, Simon, and thanks for this awesome presentation. Just as a reminder to everyone to ask a question, click on the Q&A button located in the toolbar on the top left side of your screen, type your question, and then click the Ask button. One of the questions that came through was, does the configure done using the iOS SDK need to be done at one time for each and every device, or can it be applied to many devices easily?
Yeah, so the question was, if I were to paraphrase, does the configuration profile have to be applied to each device separately? So yes, if you are using, say the kind of USB cable, you're going to have physical access to that device to load the profile on. Of course, you can save this profile. So I could create a profile called My Organization and then deploy that to many devices without having to reset it up every time. If you're looking for more of a mass adoption, however, certainly Microsoft Exchange is going to be the way of getting the passcode policy most easily down to devices if you are using Exchange as your email system. If you are not, then you're probably going to take that mobile config. You're going to offer it maybe through an intranet site, look like a SharePoint site, or even consider one of the 3 MDM vendors to actually push that to devices today.
Thank you, Simon. If anyone has any more questions, please feel free to type them in at this time. In the meantime, I'm going to click through a few polling questions, and we greatly appreciate your feedback. The first question, was this content helpful for your business? Yes or no? Great, thank you everyone. Next question. Please rate the presentation content, excellent, good, or poor. Great, thank you. Last question. Would you like us to schedule a follow-up? Yes or no? Great, thank you, everyone. If you have any further questions about this presentation, please feel free to email Simon at the email address provided on the slide. Sorry about that. We'll be forwarding out a recorded version of the presentation once it becomes available. Again, thank you so much, everyone, for joining us today. We look forward to seeing you on our next webcast. You're now free to disconnect. Thank you.